Example number 12. For the following function, we're going to find the critical values and the open intervals where the function is increasing and or decreasing. So this is a function composed of two functions that are being multiplied. So what we're going to do is we're going to use the product rule. The product rule, as a reminder, says first times the derivative of the second plus second times the derivative of the first. So my first function is just x. So my first function prime is just 1. My second function is e to the negative 8x. So my second function prime is negative 8 times e to the negative 8x. Remember, the chain rule says you have to tack on the derivative of that exponent. Well, I just wrote it in the front. So let's see what we have for f prime of x. We have the first times the derivative of the second, negative 8 e to the negative 8x, plus the second, e to the negative 8x, times the derivative of the first, which is 1. And I'll clean this up a little bit by bringing the negative 8 to the front, then the x, e to the negative 8x, and that x can go in the front or the back. It just fits better if you put it in front of the e. And then this is just plus e to the negative 8x. Now I have a common factor of e to the negative 8x. Both of those terms have an e to the negative 8x. So I'll be left with negative 8 times x plus 1, since I factored out this entire term. So now we're going to set each of these factors equal to 0. E to the negative 8x is 0, and negative 8x plus 1 is 0. Now let's talk about this e base for a minute. E is a constant. Just like pi, everybody remembers that pi is approximately 3.14. Pi is a constant. When you see a pi in a math problem, you know it's about 3. Well, e is another constant, and it's about 2.71. So this is a positive number raised to an exponent. And it doesn't matter what that exponent is. When you have a positive number raised to an exponent, you're going to get a positive. And you're never going to get a 0. Even if you raise this whole thing to the 0, you get a 1. There's no way to get a 0 from that first factor. So no critical numbers come from this. So no critical numbers. Okay, now negative 8x plus 1, however, can be solved for x. Subtract a 1. Negative 8x equals negative 1. Divide by negative 8. And you get x is 1/8. Now that's just a fraction, 1/8. You can get a decimal estimate on your calculator. We take our critical number and we put it on the number line. And we pick a test point on the left. 0 is smaller than 1/8. And a test point on the right, and I'll just pick a 1. That's bigger than 1/8. I have to test my points in my derivative. So my first test point in the derivative is 0. That's going to be e to the negative 8 times 0. Negative 8 times 0 plus 1 is e to the 0 times 0 plus 1. So this is e to the 0. And anytime you have any base raised to a 0 power, that value is 1, and 1 is a positive number. So the left region is positive, which means the function's increasing on this side. Now, on the right side of my critical number 1/8, I'm going to substitute a 1 into my derivative. E to the negative 8 times 1 times negative 8 times 1 plus 1. And this is e to the negative 8. And this is negative 8 plus 1. So that's going to put an e to the 8th in my denominator and then a negative 7 in my numerator. So I have a negative divided by a positive. So this side is negative. So this side will be decreasing. So our answer is we have one critical number, and that is x equals 1/8. It is increasing on the interval from negative infinity until we get to 1/8. It is decreasing starting with 1/8 and continues to increase to infinity. So this is our final answer.